Hello, and thank you very much for signing up for this course. I'm very pleased to have the opportunity to teach you about the most important functionalities of SAP Extended Warehouse Management and show you the module is working together with S/4HANA. Understanding how the Extended Warehouse Management module is working has become very important for all SAP professionals, as EWM is now a fully integrated component of the core S/4HANA Enterprise Management solution. If you have worked with S/4HANA, you know that Extended Warehouse Management is now embedded in S/4, and SAP has announced that EWM will be fully replacing the old Warehouse Management module that was part of the ECC, the predecessor of S/4HANA. EWM has a reputation of being a complex product to learn, which in many cases is true. But once you have mastered the basic, the more advanced functionalities of the module start to become much easier to understand. The whole purpose of this course is to give you a crystal clear understanding of the basic concepts and functionalities of EWM. This will be done by building and executing end-to-end scenarios in the system that show you how things actually work in practice. This course is part 1 of my S/4HANA and EWM training course series. The focus of this course will be with the inbound and outbound processes which form the core of the EWM. After this course, you will be able to expand the scenarios created during this course as you continue to learn about EWM yourself, or you can continue with the other courses part of this series. The structure of this course is the following. We will first start with a short slide set that introduces the fundamentals of EWM and the key concepts and terminology related to the module. After the short introduction session, we will have a quick demo that will give you a small taste of how the system is working in practice. After the demo, we have a review of the basic integration settings required to connect S/4HANA and EWM. After this chapter, we start our deep dive into EWM-related organizational structures and system configuration options. As there are many configuration settings that are difficult to understand without a practical example, I try to be as concise as possible, as the main focus of this course will be the practical scenarios we will be executing in the system. We will be first reviewing organizational and warehouse structures in EWM and then examining the key cross-process settings available in the system. After we have finished maintaining the required structures and settings, we start executing our end-to-end scenarios for inbound and outbound processes. During the scenarios, we will be revisiting the key configuration settings we have maintained. Before we start our lesson, a word about the prerequisites for taking this course. I'm assuming that you have some basic user experience with SAP and are somewhat aware of the basic organizational structures in SAP, like company codes and plants. But if you have, for example, sometimes created a new plant in SAP, you have enough knowledge to complete this course without any problems. And now, it's time to start learning how Extended Warehouse Management in SAP is working. I can guarantee that by the end of this course, you will have an excellent understanding of the basics of EWM and are able to create complex inbound and outbound scenarios in the system. In this lesson, I will be introducing the most important functionalities and concepts related to Extended Warehouse Management. This lesson is mostly aimed for students who are not yet familiar with the basic terminology of EWM. But most probably, many of you already have some knowledge or experience with EWM and are taking this course to have a better understanding how to execute end-to-end processes in the system. If you are already familiar with the very basics of EWM, you can just quickly glance through or completely skip this lesson and move directly to the system demo that comes after this. But if you don't mind watching a few slides before we start working in the actual system, I'm sure this lesson won't be a complete waste of your time. Before we start discussing about Extended Warehouse Management, let's take one step back and look at things from the SAP product portfolio perspective. As you know, SAP is all about S/4HANA at the moment. I'm not going to talk about the HANA database architecture because I know you have probably heard tens of presentations about this topic already. What I want to make sure that you are familiar with is the latest product names that SAP is using for their S/4HANA solutions, as SAP has a bad habit of constantly renaming their products and thus causing confusion among users. Before we talk about S4, let's take a look back and see how different solutions were organized during the time of R3. The main ERP product used to be called R3, which was later renamed as SAP ERP Central Component, or ECC. ECC consists of various modules like finance, controlling, material management, production planning, and so on. In addition to these main modules listed here, there are also many others, and for all the main modules, there are also countless submodules. An organization can decide which of these modules are needed or useful for its business. Next, let's see how things look with S/4HANA. The underlying technology might have changed with the introduction of HANA Database Management System, but from the functional perspective, things have not changed that much. Just like with ECC, there is one main component which consists of various modules. The new core product by SAP is called S4 HANA Enterprise Management, which is usually just referred to as S4 HANA. Sometimes the word digital core is also used. With S4 HANA, SAP does not use the words ERP or ECC anymore. The word ECC is reserved only for the R3-based ERP, which, as we all know, will not be supported for much longer in the future. From the end user point of view, there has not been that many changes. If you have user experience with ECC, you also know how to use S4 HANA. However, SAP has now started to put a lot of efforts to promote Fiori to be used as the main user interface, so it might be that the good old SAP GUI will not be seen by business users anymore in the future. As you can probably guess, Extended Warehouse Management is part of the S4 HANA supply chain module. When EWM is deployed as part of this supply chain module, this is called Embedded Extended Warehouse Management. In addition to the embedded deployment, it is also possible to deploy EWM using the decentralized deployment option. This means that instead of using the embedded EWM available within the standard S4 HANA supply chain, EWM module is deployed as a separate system that runs outside of the core S4. Extended Warehouse Management module was first introduced by SAP as an external module. Before S4 HANA version 1610, EWM needed to be always deployed on a separate server environment, and data was moved between EWM and S4 through a CIF core interface. But since HANA 1610, EWM has been available as an embedded component part of the supply chain functionality. Selecting whether a centralized or decentralized approach is best for your organization can be tricky, as both approaches have their strengths and weaknesses. Let's first talk about the embedded deployment option. The main benefit of centralized or embedded EWM is that there is no need for a CIF interface that sends transactional data and material master data between EWM and core ERP. The same master data is shared between other S4 HANA modules and EWM. But as we will learn during this course, there are still some basic integration settings that need to be maintained between S4 and embedded EWM. These settings will be the topic of the second chapter of this course. Embedded EWM means simpler IT landscape and easier system implementation, as EWM will be part of the standard supply chain module. This approach also allows the elimination of the use of extra document postings like outbound delivery requests, inbound delivery requests, and posting change requests that are required by the decentralized EWM. However, the embedded approach is not always superior to the decentralized approach, and running a decentralized EWM also has multiple advantages. The decentralized EWM offers additional functionality and features that are not supported by the centralized module. SAP is slowly implementing more features for the embedded version, but based on the longer-term guidance from SAP, the decentralized EWM will always have more features and options than the centralized EWM. The decentralized approach allows you also to connect multiple S/4HANA instances to a single EWM system, and the single EWM can share harmonized master data with all the different S/4 systems. As you know, large corporations are usually running different S/4 instances for different geographical locations or business units. In these cases, decentralized EWM can be more suitable than the centralized approach. Decentralized option can also provide a better ability to handle higher volume of warehouse transactions. When EWM is running on a separate server environment, system performance of other S/4 modules is not affected. SAP is recommending the decentralized approach for companies with complex warehouse operations. But if your company is not running a large number of different S/4 instances simultaneously, and logistics is not the very core of your business, embedded deployment is usually the best approach. During this course, I will be using embedded EWM to create the end-to-end scenarios for the inbound and outbound processes. But it's possible for you to follow this course even if you are using decentralized EWM. All of the EWM-specific configuration settings we are examining during this course are relevant for both deployment options. At this point, some of you might be asking, what is the relationship between the original warehouse management module that is part of the ECC? As you probably know, WM submodule is part of the MM module in ECC. SAP has stated that this original WM module will not be part of SAP's product portfolio in the future and will be fully replaced by EWM. However, the warehouse management module is still available within S/4HANA through a compatibility package provided by SAP. This means that it's possible to continue to use both WM and embedded EWM in S/4. You can use WM for certain warehouses and EWM for others within the same S/4 environment. The only restriction is that it's not possible to use both WM and EWM for the same warehouse. So, when you are moving from ECC to S/4 and are using WM, it's not mandatory to replace WM with EWM. However, SAP is providing specific migration tools to facilitate the change from WM to EWM. Next, we need to talk about basic and extended warehouse management. Here you can see how the different functionalities of EWM are divided into basic and advanced functionalities. Basic warehouse management covers all the basic warehouse management functionalities needed by a non-complex warehouse. All of its features are part of the standard S/4HANA, and your company does not need any additional licenses from SAP to use these basic functionalities. The functionalities provided by advanced warehouse management are often required by larger and more complex warehouses. If your company wants to use these functionalities, an additional license from SAP is needed. During this course, we will be focusing on warehouse structures and inbound and outbound processes. The other processes are covered by the next course as part of this training series. Next, let's have a quick look at the organizational structures available in Extended Warehouse Management. But before we start to talk about EWM-specific structures, let's have a quick look at the overall organizational nodes in S/4, even though you are probably already familiar with them. As you know, company code represents an individual legal entity. Global corporations usually set up a legal entity in all the countries where they are doing business, and a separate company code is created for all these business entities in SAP. The next structure in our hierarchy is plant. Plants represent, for example, factories, warehouses, and distribution centers. One company code can include many plants, but a plant can only be linked with a single company code. When stocks are moved in or out from a plant, both a material document and an accounting document is created. A storage location is a physical place connected to a plant. Usually, a storage location is physically inside a plant, but can also be located somewhere else or be just a logical location instead of a real physical location. In addition to a plant that can also represent a warehouse, there is also a specific organizational node created just for warehouses. A warehouse is an important structure in S4 because we are linking S4 warehouse numbers with EWM warehouse codes. This link forms a crucial connection between the core S4 and EWM module. We will examine how this linking is done during the third chapter of this course. You can also see from this slide that it's possible to link storage locations from multiple different plants with the same S4 warehouse code, so S4 warehouses are not necessarily plant-specific. Next, let's look at organizational nodes in Extended Warehouse Management. A warehouse code represents the highest level organizational entity within EWM, meaning that all the other organizational nodes are linked with a warehouse code. As you remember, it is possible to link an S4 warehouse with multiple plants that can even be linked with different company codes. EWM is using a concept called party entitled to dispose to determine which stocks inside a warehouse is owned by which plant. We will talk more about this later during this course. A warehouse code is linked with availability groups. Availability groups control which stocks are available in your warehouse for different processes like picking. Later in this course, we will see how storage locations in S4 are linked with availability groups and how this linkage is also very important for connecting S4 and EWM. Availability groups are further divided into different stock types. A warehouse code in S4 needs to be also linked with a supply chain unit. A supply chain unit is mostly used to maintain the geographical location and address for your warehouse or for other nodes in your supply chain. Next, let's have a brief review of the warehouse structures available in EWM. These structures are used to map and separate different physical areas in your warehouse based on their characteristics. When implementing EWM, you are using these different warehouse structures to model your actual physical warehouse into the system. The warehouse code in EWM that we just already discussed is the highest node among the structural elements in EWM. The next node is called storage type, which is further divided into storage sections. A storage section consists of storage bins that are actually storing the physical products. A storage type is usually a physically distinct area in a warehouse, but can also be used for logical subareas. Some common examples of storage types are high racks, bulk storage areas, and fixed bin storage areas. Storage types are not only used for the final put-away storage areas, but they are also used for different types of various staging areas and work centers around a warehouse. Storage types are very important elements, and most of the key settings related to put-away strategies and stock removal strategies are maintained on a storage type level. Storage sections are used to group similar types of storage bins together. For example, a common way to use storage sections is to divide storage bins into bins for fast-moving items and bins for low-moving items. The bins meant for fast-moving items are located on the first level of a rack, and the bins for slow-moving items are located on the higher levels of the racks. The storage sections can be used as one of the parameters that the system is checking when the most suitable storage bin is selected for products. However, it's not always necessary for you to create storage sections for all your storage bins. Sometimes storage types and storage bins are enough for certain areas in your warehouse. A storage bin is the smallest fixed space in the warehouse used to store products. A storage bin can represent an exact location where a product is stored in the warehouse. EWM allows you to name your bins using an alphanumerical code with a maximum of 18 digits. Also, the different staging and work areas are divided into different storage bins, so a storage bin in EWM does not need to be a physical bin or a rack, but can represent a larger warehouse floor area. We will later see that there is a large number of settings that you can maintain for storage bins. For example, the size and storing capacity of each of the storage bins. Next, let's have a few words about the inbound process in EWM. The process of receiving goods to your warehouse and then placing them into storage bins is called put away. A typical warehouse has many different types of storage areas and storage bins which are meant for different types of products. For example, large containers are stored on the warehouse floor, and smaller products are placed in various types of racks. The rules that determine where specific products should be stored are called put away strategies. These put away strategies are among the most important functionalities in EWM. EWM module provides 8 standard put away strategies that you can use in your warehouse. It's also possible for you to modify these standard strategies and make your own rules. Together with the product-specific settings maintained using product master data, the system is using the put-away strategies to automatically determine the most suitable storage bin for received products. The purpose of these strategies is to optimize the use of the warehouse space and maximize the efficiency of your inbound process. Let's very quickly go through these standard strategies in EWM. But before we start, I want to warn you that you're going to see a lot of configuration settings in the coming slides that don't mean anything to you yet. So you can just ignore these settings for now, as we will be returning to these slides later when we are examining these settings in the system. The first strategy is called manual entry. This strategy means that the system will not automatically determine the best storage bin where the product should be placed, but only proposes which storage type in your warehouse should be used. A warehouse operator can select the most suitable storage bin herself during put away. Here you can see the key system settings that you need to select if you want to use this strategy. All these settings are storage type specific, so one storage type can only use one strategy, but different storage types in your warehouse can use different strategies. As I said before, we will be going through these settings in a detailed level later when we are examining storage type level configuration options. The next strategy is called fixed bin storage. A fixed bin means that a specific product is assigned permanently to one or more storage bins and is always stored there. Even if a fixed bin runs out of stock, the linkage with a specific product will remain. When fixed bins are used, you can either assign products to storage bins manually or let the system do the assignment automatically. If there is no fixed bin for a product yet, or the assigned fixed bins are full, the system creates a new fixed bin assignment automatically during put away. The general storage strategy means that the system looks for a storage bin in a general storage area. A general storage area has only a single storage bin for each storage section. There are no product-related restrictions, and different kinds of products and handling units can be stored in the same storage bin. Addition to existing stock strategy means that the system prefers to put away stock in storage bins that already contain stock of the same product. If there is no more space in the storage bin with existing stock, the system searches for the next empty bin to place the products. Different products do not have fixed bins, but the next suitable free bin is selected. The next strategy, empty storage bin, can be used when you want the system to always propose an empty storage bin. This strategy fits high rack storage and shelf storage where products are organized randomly. Near fixed picking bin is a special strategy that can be used when you put away products in a reserve storage area. The common setup is that the system will first search for a fixed bin based on the fixed bin storage strategy. If a fixed bin is not available, the system uses this near fixed picking bin strategy to search for a bin in a reserve storage type that is as close as possible to the fixed storage bin of the product. The pallet storage strategy is used to store different sizes of pallets in the most efficient way. This strategy can also be used for other handling units than pallets, but pallets are the most common example of this. Let's say that you have a high rack storage bins that can fit either 3 Euro pallets or 2 industrial size pallets. After a Euro pallet has been placed in this type of bin, the system divides the bin into 3 subsections as it knows that the bin can fit 3 pallets of this size. After this, only Euro pallets can be added to this same bin and other pallet sizes are not allowed. When the bin becomes fully empty again, the subsections are automatically deleted and you can place a pallet of any size into the bin again. We will later be examining the storage bin sectioning configuration, and we will discuss how to define the rules of many pallets of different sizes that can fit into different storage bins. Bulk storage strategy is usually used for products that are handled in large quantities and require a large amount of storage space. Racks are not used for bulk storage, but warehouse floor is divided into rows. A storage bin is created to represent each of the rows. Each row can have only one type of handling units and not different sizes of containers. We will later discuss how you can define the rules how many handling units of different sizes can be stacked for a single bulk storage bin. I know I have gone through a lot of these different strategies quite quickly, so no need to worry if you did not fully understand all the differences between the different strategies. The best way to fully understand the strategies is to set up all of these strategies in your practice environment for different storage types, following the settings listed in these slides, and then making your own experience how the system is behaving under different strategies. During this course, we will be focusing on the pallet storage strategy and the bulk storage strategy, as these strategies are the most complex among these strategies. Next, let's talk briefly about the outbound process in EWM. Stock removal strategies are as vital a part of warehouse management as the rules for stock put away. Stock removal strategies decide where the system is searching and selecting the stocks that need to be removed from your warehouse. Just like with put away, EWM is offering standard strategies that can be used for stock removal. Let's briefly go through these standard strategies available in the system. The first in, first out strategy is probably familiar to all of us. This strategy means that the oldest quantity from the storage type is selected first. The most suitable storage type is selected based on the storage type search sequence settings that we will be examining later. The age of a quant is based on the date when goods receipt was posted for the products. This date can also be changed manually during goods receipt. Here you can see the key settings you need to maintain if you wish to use this strategy. For put-away strategies we examined earlier, the key settings are maintained in storage type level configuration. But for stock removal strategies, the key settings are maintained behind multiple configuration transactions that can be found under goods issue strategies. We will carefully go through all these settings during the fourth chapter of this course. The second stock removal strategy is called stringent FIFO. This means that the system will always select the oldest quant from the entire warehouse instead of first selecting the most suitable storage type based on the search sequence settings. The key settings required for the stringent FIFO are the same as for the regular FIFO strategy. The only difference is that for stringent FIFO, you also need to define and assign storage type groups. The next strategy is called last in, first out, which is also very familiar to you. LIFO means that the system will select the last quant that was placed in the stock. This strategy is used, for example, when heavy containers are stacked on top of each other, and always picking the oldest quants would be very inconvenient. The key settings needed for this strategy are the same as for FIFO. The only difference is that your sort criterion goes from newest to oldest when you are configuring stock removal rule settings. The next strategy is called partial quantities first. The goal of this strategy is to keep the number of partial handling units in one storage type as low as possible. This strategy is relevant if you have defined standard handling units for some of your products, meaning that you have defined what is the standard number of a certain product inside a certain handling unit. If the number of products is less than the standard quantity, the handling unit is considered as partial handling unit. If the warehouse task is to remove a standard HU quantity of products from stock, the system will propose to pick a full handling unit. But if the task is to pick a smaller quantity than the standard HU quantity, the system will always select products that are part of partial handling units instead of proposing to break down full handling units. The next strategy is called stock removal suggestion according to quantity. This strategy means that the stocks to be picked depend on the quantity in the warehouse task. You can, for example, use two different storage types for the same product based on the handling unit quantity. The system will check if the needed quantity is less than or equal to the quantity of the standard HU and select the correct storage type based on this. The next strategy is called shelf life expiration date, which means that the products with the oldest shelf life expiration dates are picked from stock first. This strategy requires that shelf life expiration dates have been maintained for the products. The last standard stock removal strategy is called fixed storage bin. This strategy means that the system uses the fixed storage bins that have been defined for a product to select the stocks that should be picked. Next, let's have a quick look at the most important master data items in EWM. As you know, in SAP, all your finished goods and raw materials are created to the system using Material Master. But in EWM, the term product is used instead of a term material, and we are using product master data instead of material master data. The same material data is shared between S4 and EWM, but you still need to expand your materials in EWM before you can use them as products. In addition to actual goods that you are storing in your warehouse, you can also maintain various types of packing materials in EWM. A packing material can be, for example, a pallet or a carton box. When a certain number of products are packed using a packing material, a handling unit is created. Handling units are usually the most convenient way to handle your stocks in EWM. A handling unit has a unique identification number, and you can track the exact location of a handling unit in a warehouse. You can also create nested handling units by, for example, placing multiple boxes on a pallet. In addition to handling units, EWM is handling stocks as quants. A quant represents the stock of a specific product with the same characteristics in one storage bin or in one handling unit. The system manages different batches of a product as different quants. When you place a product into an empty storage bin, the system creates a quant into this bin. You can increase the stock quantity of a quant by adding to the existing stock. When you remove the stocks from a bin, the system automatically deletes the quant. Next, let's have a few words about warehouse tasks and orders. When stocks are moved inside a warehouse, this is done using a warehouse task. A warehouse task is a document that tells which product or handling unit is being moved, the stock quantity that is being moved, and the source bin and destination bin of the movement. After a warehouse task has been confirmed, it means that the stocks have arrived at their destination bin. Warehouse tasks are grouped together into a warehouse order based on warehouse order creation rules you have maintained. A warehouse order can then be assigned for a specific warehouse workers to be executed. A warehouse request is a planning document that can be converted into a warehouse task. We will later see how the system is automatically creating warehouse requests for inbound and outbound deliveries. In addition to sectioning your warehouse into different storage types based on the physical layout, you can also use activity areas to optimize the activities performed in your warehouse. You can use the activity areas to determine which warehouse tasks should be performed by which warehouse worker, so executing the task will be as efficient as possible. Activity areas are also used for bin sorting, which means sequencing the warehouse tasks the most efficient way possible. For example, if a warehouse operator has a task to pick 10 different products from 10 different bins, bin sorting is used to define the optimal picking order that minimizes the distance that the warehouse worker needs to move between different bins. We have now finished our review of the key functionalities and concepts in Extended Warehouse Management. I want to thank you for your attention so far, as I know how dull it can be to just look at slides instead of playing around in the system. But I'm happy to tell you that these were pretty much all the slides I will be showing you during this course, and from now on, we will be learning by using the actual system. In the next lesson, I will give you a short demo in the system so you can immediately see all the concepts discussed during this lesson in practice. It's time to start our introduction demo, how the system is actually working in practice. In this demo, I will introduce you the key functionalities of the inbound process in EWM and show you how S/4HANA and EWM are integrated together. We will be sending an order to our supplier and then receiving the ordered goods into our warehouse. When the goods arrive to our warehouse, we will first unload the products into the inbound staging area, then move the goods to the deconsolidation area, and after this, move the products to their final put-away storage bin. The purpose of this demo is just to give you a high-level understanding of how EWM is actually working. We will be going through this scenario in a much more detailed level later, so no need to worry if you're not able to fully understand every step of the inbound process yet. I promise that everything will become fully clear to you during this course. It's time to log into the system and start our demo. The first step is to create a purchase order for our supplier. I open the transaction used to create new orders. I'm entering all the required data for the order, including supplier information, organizational structure data, and material details. After all the required fields have been completed, I press Save and the system will create the order. The next step is to create an inbound delivery based on the order. I want to highlight that we are now creating an inbound delivery in S4 and not yet working with EWM. After I've saved this inbound delivery, the document is automatically distributed and a corresponding inbound delivery is created in EWM. The system knows that this inbound delivery is EWM relevant based on the plant and storage location of the delivery. Next, it's time to start examining what happens in EWM during inbound delivery. I open a transaction that is used to examine EWM inbound delivery documents. This document is showing all the details related to the delivery we are about to receive into our warehouse. Our goal is to now move the received products to a suitable storage bin in our warehouse. The first thing I need to do is create a handling unit for the received products. Let's assume that the products are packed on a single pallet when they arrive to our warehouse. Using this transaction, I will be creating a handling unit using a pallet as the packing material and then dragging the products inside the handling unit. This means that all the products we have ordered are now placed on a pallet and we can manage these stocks as a handling unit. The next step is to unload the products from our supplier's truck to the inbound staging area of our warehouse. We will be doing this unloading by using a warehouse task. I select the handling unit we have just created and then use this button to create a warehouse task for the handling unit. Creating a warehouse task is not enough, but we also need to confirm the task. A warehouse task just tells a warehouse worker what to do, and the actual movement is not done before a worker has confirmed the task. Let's see how we can confirm the task. In an actual warehouse, a warehouse operator would use a handheld device with a custom user interface to confirm warehouse tasks, but I'm using a quicker way to do this. After I've confirmed the first warehouse task, the system automatically creates two more tasks for this delivery. This task here is used to move the handling unit to a deconsolidation area, and the other task is used to move the handling unit to the final storage bin. As you can see, I have configured the system to automatically assign these specific steps when this type of product is being received to our warehouse. Different kinds of process steps might be required for different types of products, and we will be using a lot of time during this course to examine how to create and assign various process steps during the inbound process. You can also see that the best storage bin where the handling unit would be stored is automatically selected. Understanding how to create the rules that the system is using to select the most suitable storage type, section, and bin for different products is also among the most important topics of this course. Let's confirm the task that is moving the handling unit from the inbound staging area to the deconsolidation area. The deconsolidation area is used to deconsolidate and repack the products in a way which allows them to be stored the most efficient way possible. The deconsolidation is done in the system by using a work center. Let's open the work center I have created to be used for deconsolidation. This work center transaction can be used to divide the stocks into different handling units. I'm satisfied with the way the supplier originally packed these products, so I will just press this button here to complete the deconsolidation process. After this, we can just confirm the final warehouse task, which means that the products have been placed into their final put-away location. Let's have a final look at the inbound delivery document. We can see that the status of this document is fully completed. Goods receipt has been done automatically when we confirmed the first warehouse order, and the goods receipt has been posted in S4 HANA at the same time. This completes our short demo of the inbound process in EWM. As I said before, the purpose of this demo was just to give a general feeling how EWM is functioning. The logic behind all the steps will soon become fully clear to you. We have now finished the first chapter of this course. In the next chapter, we review the basic integration settings required to connect S4 HANA and embedded EWM. See you in the next chapter.